Hi, so this is the recording of the final exam review if you're watching this on Blackboard later. So we're starting with the first question that is analyzing different types of sets. So the first question says to how many elements are in C intersect R, and we can recall that intersect correlates to and, so you just look at the part of the set that is shared between C and R, and there are 6 things in there. So there are 6 elements in C intersect R. And now we want to see how many sets are in the union of R and C. So right, this is the union, so this is OR. So this union, anything that's in C or R, so we look at both of them combined. So we look at all of C, and we look at all of R, and we see how many things are in this. And so whenever we look, we have 10 that are just in C, 6 that are in both of them, and 3 that are just in R, for a total of 19. Okay, so the next question is how many things are in R complement? So I'm going to erase this shading. So like a lot of you did on exam, it's really helpful if you want to use different colors to shade different things. So now we're going to look at R complement. So just means everything that's not in R. So we're just going to look at everything that's not in R. So complements are typically where we consider this universal set more, right? The box that the circles live in. So we're going to look at everything that's in the box that's not in the circle corresponding to R. So that's going to be the 10 things that are just in C. Oh, sorry. It's going to be the 10 things that are just in C plus the 9 things that are not in R and not in C, right? That are just outside the circles, but still in the box. So that's going to be a total of 19. And then lastly, we are asked to look at complement of that. So to do that, it's probably easiest to look at inside the parentheses first, just like we do with order of operations. So we look at C intersect R, and that's these 6 things, but we want the complement of that. So we want everything that's not those 6 things. So that involves everything that's just in C. That involves everything that's just in R, and then everything that's not in either of them here in this outside. So it's going to be everything besides the intersection. So when we add up those things, there's 10 things that are just in C, 3 things that are just in R, and 9 things that are just in the universal set, which is in the box. So when we add these things up, we're going to get 22. So you should be able to, for the final, identify all of these types of sets, unions, intersections, complements, find how many like a value corresponding to each of those types of sets, or do a shading of these types of sets. May also be asked to shade a specific union or intersection that's given. Okay, any questions on this one? Okay, so the second one, again, this looks really similar to a question from the first exam. So we're given an arithmetic sequence. And if you remember the definitions of arithmetic and geometric, they're going to help you out a lot. So the arithmetic just means to add, right? Arithmetic is adding, geometric is multiplying. So you can see whenever you're trying to find the pattern for these, knowing that arithmetic corresponds to addition and geometric corresponds to multiplication can help you figure out the pattern here. So going from 13 to 26, because it's said to be arithmetic, we know we're going to add something. So what's 26 minus 13? 6 minus 3 is 3. 2 minus 1 is 1. So we're going to add 13 to get here. And then the arithmetic sequences will add the same thing every time, but we can just double check that just in case we made a mistake whenever we subtracted the first time. 39 minus 26. 9 minus 6 is 3. 3 minus 2 is 1. So we're adding 13 again. And you can check that that works for this one as well. So if we're adding 13 every time, then the next term is going to take 52 and add 13, which is going to give us 65. And then we need to find the nth term. So with the nth term, it matters what position the numbers are in. So if you're trying to find the nth term, what I would recommend, kind of like when we underline the place value and label it underneath a blank, I would recommend doing that for these sequences. So we have 13, 26, 39, 52. So this is the first term, 26 is the second term, 39 is the third term, 52 is the fourth term. And so if you remember the general form for arithmetic and geometric sequences, that's great. If you don't, you can see how the pattern works here, right? We're adding 13 each time. So we're going to take the position of our term in our sequence, and we're going to multiply it by 13 because we're adding 1 in our position each time. Multiplying by 13 corresponds to adding 13 in each position. And you can see that the first term is just 13 times 1. The second term is just 13 times 2. The third term is 13 times 3. The fourth term is 13 times 4. And so the nth term is just going to be 13 times n. And so this one is an easier example because, right, this is the simplest that a sequence could be, is just one number times the position. So remember that it may be shifted. For example, we've seen sequences like 13n minus 2. If you're adding 13 every time, but for example, the sequence starts at 11. So just keep that in mind that these sequences may be shifted, they may be multiplying. We may also have sequences of squares and cubes. So if these things sound unfamiliar to you and you really don't remember what it is, I would recommend going back to looking at when we did this in chapter 1. So this was like the 1.1.5 supplement with sequences thing. Okay, so now the 15th term, this one should be easy given b. So if you know that the nth term is just multiplied by 13, the 15th term, you're just going to multiply 15 times 13. And I don't know how to do that off the top of my head. So 15 times 13, 3 times 5 is 15, carry the 1. 1 times 3 is 3, plus 4, plus 1 is 4. Add a 0, cross out the 3. 15 times 1 is 15. So this is 195. Yeah, and I expect you to write down all your scratch work. That is the one direction that has been on every single exam, is to show all of your work. You may have noticed on previous exams, you get points counted off if you don't show your scratch work. Yeah, it helps me know that you're not cheating and using calculators and things, just because, I don't know, some of the, especially with the decimals, like we just had on the most recent exam, it's really hard to do those things in your head. So if you don't write down your scratch work, it would be hard to do those things in your head. So just write down your scratch work just to be safe. Okay, are there any questions on number 2? Okay, and I will also say that on questions that are multi-part, like this one, where to get part C, I used part B, you may have noticed on the previous exams, you will get partial credit if you have an incorrect formula right here for the nth term, but you plug it in correctly for part C, you should get partial credit for that. And if you don't, let me know. Okay, so number 3 talks about writing sets and set builder notation. So this was something that was not on the first exam, but we had homework questions over it. So this was one of the written homeworks. I think it was section 2.1. So I went and graded all of those by hand. So if you just did the WebAssign homework and then never looked at the comments, I would recommend going back and looking at the comments because this one was a type of question that a lot of people struggled with. And I gave comments to everyone on what they should have, what the answer should have been, how their answer was incorrect. So go back and look at homework 2.1 on WebAssign to see if you got these questions correct, and if you didn't, how you should have changed your answer. So remember that set builder notation looks kind of funny. So it's the set bracket, and we have some type of number, right? So this is where we specify, oops, sorry. So this is where we specify the number type such that. So this vertical bar meaning such that, and then some, typically it's some inequality or some property. So one of the hardest questions from this homework was, it was a list of prime numbers, and you had to say the property, there wasn't an inequality that you had to have. The property was, you were looking at numbers that were, whole numbers that were prime. It was essentially a set of prime numbers less than, I think, 11, something like that. So we're going to have our number type here in our first part of our set builder notation, a such that symbol, and then an inequality or a property. So when we do this, so the number type here is integers, right? So the whole numbers, gonna go on a quick tangent here because a lot of people on exam 3 mixed up the whole numbers and the integers. So, or the whole numbers and the natural numbers, I mean. So the natural numbers are the counting numbers that you can see with your fingers, 1, 2, 3, 4. The whole numbers add in 0, and then the integers add in the opposites. So add in the negative numbers. So because this set, well, we can see that it's all, I mean, things you see on a number line, right? Counting numbers, whole numbers, there's no fractions or decimals or anything. So because there's no decimals, it's not the real numbers. Because there's no fractions, it's not the rational numbers. So because it has negatives, it has to be the integers. So we can say, you can use any variable you want. I'm just going to use x. So these are the integers, right? So that's the bolded Z. So these are integers because we have negatives. And then what's the inequality or the property? So this is essentially bounding your set below and above. I know I haven't used that language before, but it's just saying, well, these are integers that are bigger than -2, right? Our smallest number in the set is -2. So x is greater than or equal to -2. And then what's the biggest number in the set is 4. So x is less than or equal to 4. And then you close the bracket. So this is not the only way to write this. You can combine these inequalities if you want. So you could say that we're looking at integers and combine the inequalities, saying that -2 is less than or equal to x is less than or equal to 4. Or if you want to use strict inequalities where you just have not less than or equal to or greater than or equal to, but just less than or greater than, you can do that as well. I'll go ahead and write an example of that because that's what a lot of people have to do on this homework because your keyboard does not have a less than or equal to sign or greater than or equal to sign. So you could just extend your bounds and have strict inequalities, right? So what is the next integer that's bigger, strictly bigger than -3 is -2. And what's the integer that's strictly less than 5? Well, that's 4, if you're looking at an integer number line. Okay, does anyone have any questions on number 3?
I had a question.
Yeah, go ahead.
With the -3 and 5 right there, what were you trying to show again on that one?
Yeah, so for this one, I was just trying to show that on the homework, a lot of people answered with strict inequalities because your keyboard doesn't, I mean, a standard computer keyboard doesn't have the less than or equal to sign. So if you remember doing these homework questions and you had to put strict inequalities rather than including the equal part, this is just an equivalent way of saying the set using a strict inequality.
Okay, but on the exam, you would want us to use the equal to sign, less than or equal to. Okay.
Any of these 3 sets are correct. It's really just your preference of how you how it makes most sense to you.
Okay. All right. Yeah. Thank you.
Thanks. Does anyone else have a question on this question? Okay, so we're going to go to number 4. So that's the questions on sets, sequences, and things like that. So these questions are in chapter order on the review. I don't anticipate they'll be in any sort of order on the final though. So now we are moving to questions from chapter 3. So we want to take a number that's not in base 10. We want to write it in an expanded form and convert it to base 10. So we've seen expanded form a lot. So we had questions over it on exam 3, and a decent amount of you forgot what expanded form was. So expanded form means that you write out things using the place values. So let's recall what place value is. So 4, 5, 3. So each of these have a different place value. So it's essentially, right, we talked about place value when we talked about number systems in section 2.2 and 2.3. So because we're in base 6, this is going to be the 6 to the 0 place. This 3, this 5 is going to be in the 6 to the 1's place. And the 4 is going to be in the 6 squared's place, right? So typically in base 10, instead of raising 6 to all of these exponents, we raise 10 to all of these exponents. But no matter what base you're in, you just raise that number to the other exponents. We see a lot of questions in this class about base 5 and base 8. So it would just be 5 to the 0, 5 to the 1, 5 squared. And similarly, 8 to the 0, 8 to the 1, 8 squared. And so this is the place value that's associated to these digits. So when we write this in expanded form, we just write it as a sum. So this first 4 tells us that the value there is 4 times 6 squared. The 5 tells us that the value there that comes from that 1's place, or the long's place, however you want to think about it. This is 5 times 6 to the first. And the value that comes in the 1's place, or the 6 to the 0 place, is 3 times 6 to the 0. So this is that number in expanded form. So I guess I should have written 4, 5, 3, 6. So this is that number written in expanded form. And the reason that we write these numbers in expanded form when they're in different bases is because then we can just perform these operations, these additions and multiplications, to find the value in base 10. So you can just kind of keep going along these inequalities. So this is 4 times 36 plus 5 times 6 plus 3 times, I'm just going to put 6 to the 0 as 1. And you'll notice that in this step, I took away the parentheses. And I can do that because we have the order of operations that tells us that we're going to multiply before we add. So you can take away those parentheses and it's still the same thing. Okay, so now we're going to do the multiplication and then the addition to be consistent with the order of operations. So 36 times 4. Again, this may be something you can do in your head, but I cannot, so I'm going to write it down. 6 times 4 is 24. So we put the 4, carry the 2. 3 times 4 is 12. Add 2 is 144. Okay, so this is 144. 5 times 6 is 30. 3 times 1 is 3. And then when we add all of those things together, we get 177 base 10. So that's how you do it. So that's how you convert from a different base to base 10. So on your concepts to know sheet, it also says that you should know how to convert. And so converting to base 10 and converting from base 10. So there was a question, I believe, on the first exam that talked about converting something from base 10 to a different base. So you should be aware of how to do both of these processes. And again, this is something that there are questions like that on exam 1 and also in the homework. But you should be able to do both of these processes. Were there any questions on number 4? Okay, number 5 is continuing doing operations in different bases. So this is all still from chapter 3. So in chapter 3, we did a lot of addition, subtraction, multiplication, and division. And just to make it a little bit, to help remind you all what it's like to have to learn how to do basic operations again, we did a lot of things in different bases. And we used different models and algorithms. So you should be able to do all of the basic operations using models and algorithms for this. I guess I haven't said officially, the final's cumulative, if you haven't gathered that by now. Sorry, I should have said that. Final cumulative over all 9 chapters. I know that's a bit unfortunate. A lot of people don't like cumulative finals, but since this is the first class in a very long series of math classes, right? This one goes to 2371, which goes to 3370 and 71, and then 4370 and 71. I think it's important to have a cumulative final because you're going to need to know all of this for the next class in the series. So for number 5, we're subtracting in base 5 using base blocks. So again, sorry, I should also say you should be able to do all of these processes and also explain all of these processes. We've had a lot of questions throughout the first 3 exams that say, explain how to do this process, right? Explain how to subtract using base blocks. So you should be not only be able to do these operations with a specific example, but also write them out in sentences to explain to someone else how to do them. Okay. So we're going to, first off, when we do subtraction with base blocks, we only write down the first number. So remember that this 1 here is our unit, the 3 is a long, and the 4 is flat. So we're going to have 4 flats three longs and 1 unit. Because when we subtract using base blocks, all we do, we only draw the blocks for the first number, and then we take away the blocks for the second number. So you don't have to write these steps if it doesn't tell you to, but I will. So we draw the blocks for the first number. And then what we're going to do after we draw these blocks is we are going to take away the blocks for the second number. And when we do that, we may have to regroup some things. So when we subtract 2 for 2 base 5, we need to take away 2 units, but we don't have 2 units. So what we're going to do is we're going to take one of our longs and we're going to regroup it into 5 units. We regroup it into 5 units because this is base 5. If we were doing this operation in a different base, 1 long goes into that many units, 1 flat goes into that many longs. So because it's base 5, 1 long is 5 units. Okay, so we're going to do that. And then we're going to take them away. So we want to take away 2 units. Okay, so we did that. So now we want to take away 4 longs, right? So we've taken away this 2. Now I want to take away the 4 that's right next to it. Well, sorry about that. That wasn't so great. So we took away 2. Now we want to take away the 4. So we want to take away 4 longs, but we only have 2 longs here to take away from. So what we're going to do is we're going to take one of our flats and we are going to regroup it into 5 longs. So we're going to regroup it into 5 longs. So now we can take away 4 longs. So we're going to take away 2 that we originally had and 2 more from this regrouping. Okay, so we've taken away 4 longs. Now we need to take away 2 flats. So we have 3 flats, so we just take away 2 of them. So now we're going to see what's left and regroup if necessary. So a lot of times when we write out steps, we often have above like the last step being simplifying. So when we have base blocks, we're always going to have one of the steps being regrouping. It's essentially the simplifying for base blocks, and that's always going to be part of your list of steps. Okay, so what do we have left? We have 4 units. So we're always going to count from the bottom up just in case we need to regroup. So we only have 4 units left, so those cannot be regrouped. So we just leave them. And we have 3 longs left. Those cannot be regrouped, so we just leave them. And we have 1 flat left over. So we can't regroup or simplify it all, so we just are going to write down our answer, that 341 base 5 minus 242 base 5 is 134 base 5. And that's our answer. So make sure whenever you're doing questions where you're using models that you actually do write down your answer in the end. Even though I can see that 4 units, 3 longs, and 1 flat is 134, you should also write it down just to be safe. Are there any questions on doing operations using base blocks?
Could you explain how, so when you got the 4 units, 3 longs, and 1 flat, like, how would we have to, like, if there was 6 units, would we have to convert those units to longs?
Yeah, so if you end up somehow with 6 units, then 5 of those units would go into a long and 1 would stay as a unit. So yeah, you would need to regroup those and just kind of how I would write it is just kind of adjust and write out, well, if I regroup, then we actually have whatever your list of things would be that you have now.
Okay.
Were there any other questions on this?
And then when we, I had another question, if that's okay.
Yeah, go ahead.
When we like cross out, do we have to use different colors for taking away and then regrouping? Like I know you used red and then black.
No, you don't have to use different colors. However, you should tell me what is regrouping and what is taking away. For example, with these 3 longs, you can see based off the colors I use that the black is the regrouping and the red is taking away. So you by no means have to use different colors, but you should tell me, right, at least put next to this arrow that this arrow is a regrouping. Sorry, that kind of looks poor. I'll rewrite it. So you should say next to the arrow what you're doing. So that this is regrouping and this arrow is regrouping, just so I know what's going on. You can also explain it. So because we are in the unique situation where we use Proctorio, you can also explain it because, I mean, your video and audio is being recorded. So you can also explain it verbally if that helps you.
Thank you.
Yeah, so on using different colors, thanks for bringing this up. Please don't use red. Please don't use red or pink, just because it's really hard to see because I graded red. It's hard to see what I write and what you write. So if you can, please avoid using red or pink marker or pen or whatever you use to write. Okay, one other thing I want to say about using base blocks, because this is the only base block question on the review, is that if you use base blocks with decimals, you have to do something special. You have to specify what block represents 1. So if you have a question where you're told to do some operation with decimals using base blocks, it's not as simple as when we're dealing with whole numbers using base blocks. You have to specify what block represents 1. Oftentimes, that's going to be the flat that represents 1, and then the long will represent the tenths, and the units will represent the hundredths, but you should always specify what represents 1. Whenever we're dealing with just whole numbers, the unit will always represent 1. So yeah, just don't forget to do that if you're doing base blocks with decimals. Any other questions on base blocks? Okay, so moving to the order of operations. So this question is a little bit different. We haven't seen something like this before, where it gives you work that is, you are told that it's incorrect, and you need to fix it. So this is a really common mistake. So look at it if you haven't already and see what's going on here. So going from the first step to the second step, what happened? We multiplied. And going from the second step to the third step, we divided. And so given the order of operations as we know it, so PEMDAS, this may seem like the correct thing to do, where you multiply and then you divide. However, there was a decently long conversation about this in the lecture videos whenever we talked about order of operations. So if you don't know what I'm talking about, I would recommend going back and watching that video and seeing what I'm talking about. That we multiply and divide going left to right. So we multiply and divide going left to right. So multiplying and dividing are grouped like that, as well as addition and subtraction are grouped like that. So if you have an expression like we do here that only has multiplying and dividing, even though the M in multiply comes first in PEMDAS, multiplying and dividing are just going to go left to right. So when you do this, the correct way to do it is to take this expression that we start with, and we're going to divide first because it comes first going left to right. So then this is going to be 12 times 3, because 24 divided by 2 is 12. So then we're going to multiply and get that this is 36. So as I talked about in the lecture videos, this is just what we have chosen to do. There was no reason that this is more correct. However, it is the chosen standard that we always group multiplication and division, and we do them left to right. Similarly, we always group addition and subtraction and do them left to right. So there was a question like this on exam 2 that you had to know which order to do things, and exam 3. So if you missed a question in both exam 2 and exam 3 had a long question where you just had to simplify a bunch of things. If you missed that question on exam 2, this may be why, is that it goes left to right. Yeah. So are there any questions on the order of operations and or how to write a question like this, given that we haven't seen it before on an exam? Okay, so now that you've seen it on the review, you maybe have a question on the final that tells you to find and fix mistakes in work. So just be aware that that could be a question that pops up. Okay, now on to divisibility rules. So we had to state all of these divisibility rules on the second exam. So we're just going to go over them again, just so that you hear it one more time, because if you hear things repetitively, eventually they'll stick with you. So a number is divisible by 2. So this is in section 5.1, if you don't remember them. So the divisibility rule for 2 is that a number is even, or an equivalent way to say that it's even is it ends in 0, 2, 4, 6, or 8. So you can either say that it ends in this number or that the last digit is this number. Make sure that you say digit if you're talking about the last digit in a number. There were a decent amount of people who got points off on the second exam for using incorrect language. It's not the last number in the number, it's the last digit in the number. Okay, so then number 3, for 3, number is divisible by 3 if the sum of the digits, so again, make sure that you talk about the digits of a number, not the numbers of a number, just because that's really confusing language. So the sum of the digits is divisible by 3. 4 is that the last 2 digits are divisible by 4. 5, the number has to end in a 0 or a 5. 6, it has to be divisible by 2 and 3. 8, the last 3 digits are divisible by 8. 9, the sum of digits is divisible by 9. 10, it has to end in a 0 because we work in base 10. And 12, so the divisibility rule for 12 is not in the book, but it was in the lecture videos, and therefore you're responsible for all the material in the lecture videos. So a number is divisible by 12 if it's divisible by 3 and 4. There are equivalent ways I think with away them, like an equivalent definition. As you may have seen in some of the definition matching ones, there's more than one definition for things, but they mean the same things. So the divisibility rule for 12 was a very commonly missed question on the second exam. It's divisible by 3 and 4. I'll just explain briefly. A lot of people put the incorrect answer, that it's divisible by 2 and 6. So I'm going to briefly explain why that's incorrect. If a number is divisible by 6, you can always think of divisibility in terms of multiples. So a number is divisible by 6 if it's just a multiple of 6. And multiples of 6 are always even, right? If you think about the multiples of 6, 6, 12, 18, 24, 30, 36, 42, and so on, all of them are even. So a number that's divisible by 6 is always divisible by 2. So this won't work. This was also talked about in the lecture video specifically, and we use the example of the number 18. 18 is divisible by 6, right? 6 times 3. It's also divisible by 2, 2 times 9, but it's not divisible by 12. Because the 2 that divides 18 comes from the 6 that divides 18. So if this is confusing to you, I would recommend going back and watching the lecture video for section 5.1, because I talk about it there in probably more detail than I have right now. So this is the divisibility rules. You should know all of these. I don't think that I would ask you to create one, as we have seen that you can do, but you should know the divisibility rules for 2 through 12. Are there any questions on divisibility rules? Okay, so we'll go to the next one. So simplifying things using the order of operations. We've seen so many questions like this, right? So let's go ahead and write the order of operations up here. And I will say, as I have been grading exam 3, there's a good amount of people who write PEMDAS on their paper and then don't use it. So if you're going to write it down, use it. So multiplying and dividing, right? So this first question A, multiplying and dividing. So we know that multiplying and dividing are grouped together and they go left to right. So when we simplify this, we do division first. So 32 divided by 8 is 4. And then we do the multiplication to get 12. Okay, so multiplying and dividing go together left to right. You're always going to multiply and divide before you add and subtract. It's in the acronym, right? You're always going to do that first. Okay, so then part 2. So remember that, so this one doesn't have parentheses, but it has the absolute value symbol. So remember that when we use the order of operations, that the parentheses, so the parentheses is really all grouping. What did I call this? I think I called it grouping operations. So this includes the absolute value of things. So for that blank just means you put a number or an expression in there. It includes parentheses. It includes, right, these square brackets. It includes, not curly brackets per se, but it also includes, right, putting fractions, dividing things in a fraction like this. So remember that the parentheses includes all grouping operations. So in part B, we're going to do the grouping operations first. which is the absolute value. So the absolute value of 4 minus 6. So 4 minus 6 is negative 2. You can see that using a number line. You can see that by reordering. So even though this one's simpler to see that it's just going to be negative 2, you can rewrite it as negative. You can pull out a negative and switch the order. Negative 6 minus 4. All right, because when you distribute that negative, your 6 is negative and your 4 is positive. So these are the same thing. So this is negative times 2, which is just negative 2. Right. So there was a commonly missed question on the third exam. I know I've talked a lot about the third exam. But that's because I've been grading it all weekend. A commonly missed question was how to subtract things to get something negative. How to subtract numbers when the first number is bigger than the second number. But you can do it like this to switch it where the first number is bigger. Sorry, when the first number is bigger. Sorry, let me restate this. A common thing that people struggle with is subtracting two numbers when the first number is smaller than the second number. And you can always rewrite it into a subtraction where the first number is bigger than the second number just by essentially factoring out a negative and switching the order. Anyway, that's an aside. For this problem, we just need to know that 4 minus 6 is negative 2. And then we can take the absolute value of that, which is the absolute value of negative 2. Remember that the absolute value is the distance that the number is from 0 on the number line. So that's going to be 2. Negative 2 is 2 units away from 0 on the number line. So this is 2. And then we just fill in everything else. So we've done our parentheses, our grouping operation. So now we can move on to doing the exponent. So this is 2 divided by negative 2 times negative 3 squared. So this is also a very commonly missed question. It was on exam 2 and exam 3. That negative 3 squared or minus 3 squared, you can even think of it, it might help people to think of this as we're subtracting 3 squared. Well, there's a minus actually. That's not correct, but it's negative 3 squared. So negative 3 squared. You're not squaring negative 3 here. This is not the same as negative 3 squared. Negative 3 squared is negative 9. It's not positive 9. And this is something that a lot of people missed on the exams, is that you're not squaring the negative. The negative isn't attached to the 3 that's being squared. So this is just negative 9. So now all we're left with is multiplication and division. So we're going to do that right to left. Sorry, left to right. So 2 divided by negative 2 is negative 1. And then we're multiplying by negative 9. So we just end up here with a positive 9. Okay, so I know this one took a long time to explain just because I went on some tangents about things that were commonly missed on exams. But are there any questions about how to do any part of this problem?
What work, well, I know you showed the work off to the side here with the absolute value. Well, do you want us to like write out like how you wrote it out on this example?
No, I don't think that's necessary. A lot of these things, right? So this work that he's referencing right here, you don't need to write this out. You can just write out this. So show this work. Yeah, the work that's circled was mostly for illustration of making sure that everyone in this can see why these things are the way they are. But yeah, you don't have to show all of those steps that are circled right there.
And then, so if with the, when you got the negative 9, if there would have been parentheses just around the 3 with the, and the negative in front, it still would be negative 9?
Correct. So if you just had something like negative 3 squared, you would still only square the 3.
Okay. But if the negative is in the parentheses, then it's positive 9.
Yes.
Okay. All right. Thank you.
So were there any other questions on this one? Okay, so we're going to go on to number 9. So number 9 talks about finding the least common multiple and the greatest common factor of. Sorry about that. So number 9 talks about finding the least common multiple and the greatest common factor using the prime factorization. So essentially the easiest way to do this is a Venn diagram, right? So we find the prime factorization of both the numbers. So we know that 42 is 6 times 7, and 6 is 2 times 3. So this is 2 times 3 times 7. And 12 is 3 times 4, which is 3 times 2 times 2. So those are the prime factorizations of both the numbers. Like I said, I think the easiest way to do these questions is with a Venn diagram. So we're going to have 12 on this side and 42 on this side. So the prime factors that they have in common, so they both have a 2 and they both have a 3, right? So we have a 2 from both of them and a 3 from both of them. And what's left over in the prime factorization of 42 is a 7. And what's left over in the prime factorization of 12 is a 2. So this is the Venn diagram that we would make. So remember that the GCF is just the union, is the intersection. So we just multiply the things together that are in the intersection of these sets. So this is 2 times 3, which is 6. And the least common multiple is the union. So you just multiply every number that's present there. So 2 times 2 times 3 times 7, which is 4 times 21, which is 84. So 84. So the GCF is the intersection and the LCM is the union. I'm going to write that down. So GCF is the intersection. So it's factors that both of them share, right? The common factor says that it's shared between both of them. So that's why we look at the intersection. And then the LCM is that if a multiple is in common between both of them, it has to have all of their factors. So it's just the union of things. So the LCM is 84 and the GCF is 6. Okay, so since it's almost 3:30 and I know that this number 10 is going to take a while to write, I think this is where I'm going to stop for today. So we have 10, 11, 12, 13, 14, 15, 16, 17. So we got through 9 and we have 8 left. Okay, that's not too bad. So we got a little bit more than halfway done today. So as I said in my email this morning, in future review sessions, I'm going to finish doing this review. And then my plan was to do a review of the vocabulary that we've had that's on the vocab list. But if you don't want me to do that, that's fine. I can do whatever in these review sessions you want after we finish going through this review. Yeah, I can do whatever you want. So if you haven't filled out the survey about when you want the other final reviews to be, please do. If you want to tell me more specifically what you need, you can feel free to email me about anything about the final review or the final, and I will take that into consideration. Yeah, one thing that I haven't said in an email that I'm going to say in an email, but I'll just go ahead and say it here first, is I currently have a plan to post the exams that we've taken so far with answer keys. So every exam has had 2 different versions. So your exam may have looked different than another person's exam, depending on the time that you took it. So every exam had multiple versions. If you don't know, this is incredibly common in online classes, whenever you take exams online, to have multiple versions of an exam. So the exams had multiple versions. So my plan was to also help you all study for the final, is to post the other exams So you've only seen one version of each exam, but I think it would be really constructive for you to work the other versions of the exams that we've had, just so you have some practice, and I'll post the answer keys along with those, just so you can see, I don't know, just to have more practice problems. So that's my current plan. I cannot post the exam 3 review, sorry, the exam 3. I can't post exam 3 yet because there's still people who need to take it in a makeup exam form. So yeah, I'll post that whenever I can. But that's my plan, to give you all some extra review questions. Okay, are there any questions about anything else?
Are you gonna post like homework reviews, like extra credit like we do for all the other tests?
I hadn't planned on it. Yeah, my plan was to just kind of, the last WebAssign homework was due a week ago, and then we had the reviews due Friday. But my plan wasn't to have any more WebAssign reviews open, to just not do that anymore.
Okay.
Were there any other questions on anything?
Were you planning on having our exam 3s back to us today or tomorrow?
Yeah, that is a tricky situation. Thank you for asking. Yeah, not everyone's taken the exam yet, so it'll be sure be to you tomorrow. Yes, you will have them by tomorrow. I just need to decide the best way for me to kind of handle things, considering that they're still makeup exams. I don't know if you've noticed, I've never graded an exam this quickly, just because there are 110 of you, which is a lot of exams to grade. But you will have them by tomorrow. I know tomorrow's the drop date. Yeah, you'll have them by tomorrow. Any other questions?
On number 3, could you explain? I think you had talked about this in the lecture videos, but isn't there a specific way you want us to draw the bracket? The bracket?
You should just use a curly bracket. There's a lot of different types of brackets. I think the main ones, right? So don't use parentheses, don't use square brackets, but it's specifically the curly bracket, which is on the keyboard, typically just to the right of the P. That's what the curly bracket looks like. So yeah, just make sure to use the curly bracket. The parentheses don't mean that it's a set. The square brackets don't mean that it's a set. It's only the curly brackets that mean that it's a set. Anything else? Oh, sorry, I didn't see there was a chat. Oh, thanks. Okay, well, I think that that'll be all for today. Based on initial results from the polls, it seems as though Monday and Wednesday afternoons work for a lot of you, and then Tuesday all day. So yeah, I'll let you know as soon as I know whenever the next one will be. But if you have any questions on anything in the meantime, you can always email me. I'm not guaranteed to respond over the student holiday that's coming up this week, but you can always email me if you need anything. Okay, so I'm going to stop recording now, but you can stay and ask questions if you want, or you can leave. Thanks.